Hello and welcome to this presentation. My name is Rafaela Lenz and I'm here to present the work Effects of Igneous Intrusions on the Biomarkers Distribution Present in the Bituminous Shale of Irati Formation, Paraná Basin, Brazil. This work was done by a team from the Federal University of Rio Grande do Sul, Brazil. So this is the summary of this work. We'll pass through introduction, materials and methods, results and discussions, and then the conclusions. Biomarkers are hydrocarbon molecules that remains from the organic matter deposited with the inorganic matter that make up a sedimentary rock. And some of these compounds are sensible to maturation as they go molecular transformations such as isomerization, aromatization, alkylation, and dealkylation. And for that, they can be used as a tool to access the maturation stage. However, when we are in higher maturity stages, in higher temperatures, the thermal degradation reactions becomes more important, resulting in a decreased concentration of the majority of these compounds. So the importance of the biomarkers as a tool for the maturation assessment resides in the search for a reliable thermal maturity indicator to determine the maturity of a source rock or a crude oil. So the analysis of these biomarkers are made through different parameters. These parameters go different stages as the heat increased. The first stage is where we can see a clearly correlation with the evolution of maturation. Second stage is where the parameters enter equilibrium, and the final stage is thermal degradation stage. So the biomarkers parameters are used to assess the maturation of organic matter by comparing the abundance of a less thermally stable compound with a more thermally stable compound, and each parameter marks the maturity in a different range. The parameters that are based on the isomerization often find a maturation stability limit called equilibrium, beyond which they do not mark further increases in maturation. And when the organic matter are exposed to elevated temperature, the biomarkers undergo thermal degradation. Based on all of that, the objective of this work was to evaluate how the heat of a magmatic intrusion affects the abundance and the distribution of saturated and aromatic biomarkers, delimiting the regions of thermal degradation and equilibrium of the most usual maturity parameters. So about the geological settings, the Paraná Basin is a basin located in South America, mostly in Brazil, but also in Paraguay, Argentina, and Uruguay. It is a large Ordovician to Cretaceous intercatonic basin filled by 6 major depositional supersequences. About 2/3 of this basin is covered by volcanic rocks from the Cretaceous Serra Geral group contained in the supersequence Gondwana 3. And the presence of intrusive magmatic bodies are evidence of an unusual thermal history that resulted in the generation of hydrocarbons. The Irati Formation represents one of the most important hydrocarbon-generating formations in the Paraná Basin. It is a part of the group Passa 2 and the supersequence Gondwana 1, and it was deposited in a shallow marine environment in the interior of the Gondwana continent in the Permian period. The lithology comprehends bituminous and non-bituminous shales, and evaporites and carbonate rocks. So, as stated before, the Paraná Basin went through an atypical hydrocarbon generation process where the heat of the magmatic intrusions related to the Cretaceous Serra Geral group led to thermal maturation and degradation of part of the organic matter contained in the bituminous shales of Irati. In this profile cut of the basin, we can see the seal and the dikes intrusions, and here the Gondwana 1 supersequence that contains the Irati formation. And now on to the materials and methods. So for this work, we used 11 samples from the drill hole located in the Santa Terezinha coal field in the state of Rio Grande do Sul, Brazil, on the south of Paraná Basin, as you can see here on the image. The samples were located on top of a 35 meters thick diabase intrusion. So in this image, we can see the thickness of the diabase and the place where each of the samples were taken from also the distance from the intrusion for each of them, and as well as the vitrinite reflectance that remains very constant in the more shallow samples and increases in the more deeper samples. The TOC values remains very low, and they were used mostly for the selection of the samples. They are all shale samples. Now on to the methods. Firstly, we extract the organic extract from the sedimentary rock on a SOX-like system, and then the organic extract goes through liquid column chromatography, where we separated the saturated hydrocarbons, aromatic hydrocarbons, and the polar compounds. Then both the saturated and aromatic hydrocarbons go through gas chromatography coupled with mass spectrometry. And these are part of the chromatograms that we analyzed. For the saturated hydrocarbons, we analyzed the terpenes and stearins, and for the aromatic, the 3 aromatic stearins, the dibenzothiophenes, and the phenanthrenes. Now passing to the results and discussions. So we examined the parameters according to the intrusion distance and comparing to the vitrinite reflectance. And here we can see all the saturated parameters. Firstly, the 3-cyclic terpenes and the OPEN30, then the TSTM and Moreton and OPEN, the C29TS and OPEN29, and then the 22S and 22R for the OPEN C32, and the 20S and 20R and beta beta and alpha alpha for the stearin 29. We established 3 different zones for each of the parameters. First zone is where we can see a clearly correlation between the values of the parameters and the increase in maturation. Second zone is where the parameters remains in equilibrium. And the third zone is where we can see a high variance in the results resulting from the degradation effects. Same thing here with the aromatic parameters. First, we have the methyl-benzothiophen ratio, then we have the methylphenanthrene ratios, and the 3 aromatic, followed by the dimethyl-dibenzothiophen ratio. Some of the compounds weren't present in all the samples, and that's why we have the 3 aromatic and the dimethyl-dibenzothiophen profiles incomplete. And right here we can see the delimitations of the zones for the aromatic hydrocarbons, and we can see that there is no equilibrium zone. This graphic shows each of the zones correlating to the distance as percent intrusion thickness and the vitrinite reflectance. As we can see, all the parameters were affected by the degradation effects. The first ones were the based on the sterins, and last one was the based on terpenes. So here we can see all the parameters that shown correlation with evolution of the maturation in some range, and we can see that all of them work in different ranges. Firstly, we have the ones based on terpenes, marking the evolution of the maturation in the more shallow samples. Then we have the aromatic in the samples of the middle, and the one that showed the best correlation was the tricyclic terpene and the OPEN30 that showed the evolution of the maturation from the more shallow samples to the ones that are a little bit more deeper. Again, we can see the correlation between the maturation effects and the distance as percent of the intrusion thickness for each parameter, and we can see that the evolution of the maturation was marked until a limit that is around 2.5% of the vitrinite reflectance. So in this graphic, we can see the correlation between the equilibrium zones, the reflectance of the vitrinite, and the distance as percent intrusion thickness. We can see that the sterins ratios and the 22S, 22R open ratio already enter the profile in the equilibrium stages, and the TSTM and Moreton 30 and Open 30 enter equilibrium at around the same time in about 1.6 vitrinite reflectance. This is unusual because according to the literature, the TS and TM ratio should mark the evolution of maturation until 1.1 vitrinate reflectance, and the Moreton and Open 30 ratio should mark up until 0.7 vitrinate reflectance. But as reported in many works, samples that suffered maturation in rapid heating rate show a less mature biomarker signature than those that were maturated slowly in a sedimentary basin. So we could say that the high heating rate could be the reason why the beginning of the equilibrium stage of both these parameters is delayed to 1.6 vitrinate reflectance. These are the values where each parameter finds its equilibrium interval. The majority of them represents good correlation with what's expected in the literature, except for the 20S and 20R ratio that shown values from 0.40 to 0.42, and what's expected in the literature is 0.6. But as stated by Raymond and Murchison in 1992, rapid increases in temperature may result in certain values never reaching their endpoints, and that could be the reason why these values are so low. So we noticed that before this high variance stage, in some parameters, there are a reversal in the isomerization values, as we can see here in this graphic. This is thought to be the result of an anomalous high rate of heating. Even Strachan in 1989 noted the preferential destruction of the 20S isomer in regarding of the 20R isomer in the high temperatures. These reversals also occur here on the parameters of aromatic compounds in the more deeper samples. The two more shallow samples didn't show any good correlation with evolution of the maturity, so they are on a zone called unaffected by maturation. And the two methylphenanthranes ratio showed increase in maturation until almost 2% of vitrinate reflectance, while the methyl dibenzethiophane ratio showed the evolution until around 2.3% of vitrinate reflectance. So we can conclude that all biomarkers parameters were affected by the intrusion, shown by a highly variable distribution in the results of the samples closest to the intrusion. And the thermal evolution of the organic matter was traced by the maturation markers to a limit, which for some parameters was the stability limit of isomerization itself, and for others was the high variability caused by the thermal degradation. And finally, the trend inversion in high maturation rings occurred in parameters based in saturated and aromatic compounds. So we would like to thank FINAP and GasBAS project for the providing of the samples, and the Geoscience Institute Coal and Source Rock Study Center for the infrastructure support and the data provided for the study. These are the references cited in the presentation. And that's all. Thanks to everybody that watched it.